that even light, if light travels from here, so light will stop and start falling back, but light cannot escape from the surface of this star. So same thing when in 1783 John Michael introduced this concept. So it was thought that maybe there exist such stars and we are not able to see them because light is falling back to its surface. So they are dark stars. So at that time it was called dark stars. Later on they were called frozen stars, but the concept was removed in the end because it was seen that so dense stars might not actually exist. Yeah, but the term came back again when Einstein gave his theory of relativity, and there was a scientist named as Schwarzschild, and he used Einstein's equations rather than Newton's to derive these equations. And after very much conflict and all, finally the theory came that actually there don't exist stars like this, which are directly so dense that you have so high speed, escape speed greater than that of light. But what happens that if you have even an ordinary star, it was an Indian scientist who gave this concept, Subramanian Chandrasekhar. Yeah. So actually, what he said that there is a limit. Like say you have a star, and if it is massive enough, so its mass is very much high. He gave the concept. This is called Chandrasekhar's limit. That if this mass of the star is greater than the Chandrasekhar's limit, then the when star will die. By dying, we mean that what happens? Its fuel is getting ended up. That is, it can no longer radiate since there are nuclear reactions going on inside the star.
That
So
means die.
yeah, that is dying in the end. So when the nuclear reactions stop, so it is ended up by fuel, this radiation which is coming outward, since you are a chemistry teacher, so you must be knowing thermodynamics and all.
Yeah.
Yeah, so we know that due to this radiation it is radiating in all directions. So what is happening, due to this pressure is also created, and due to this pressure, outward force, there is an outward force. And also this star is so heavy that there is inward force of gravity. So that is outward radiation force and inward gravitational force. Until when it radiates, these forces are cancelling each other and the star is balanced. But once it stops radiating,